10 gemstones that investors secretly stop buying. In the world of high-value gemstones, some names have been trusted for decades. Their rarity, their history, and their performance at auction keeping them in private vaults and investment portfolios. But markets change. Treatments become more advanced. Supply chains shift. And when confidence is shaken, even a beautiful stone can lose its place overnight. This is not a list of unpopular gems. These are stones that serious investors once bought, then quietly removed from their holdings. Each for a reason you can verify, and each a case study in how the gemstone market rewards scarcity, transparency, and trust, and punishes anything that compromises them. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10, Citrine, the gem that was created overnight. Citrine didn't disappear from investors' portfolios because of a single catastrophic event. Its decline has been slower, quieter, and entirely predictable. Citrine, a yellow to orange quartz, has always had an approachable image. In gemological terms, it is quartz colored by trace amounts of iron, its color shaped by heat and pressure deep within the earth. In theory, natural citrine forms in rare geological conditions, where amethyst or smoky quartz is naturally heated over millions of years. In practice, however, that natural rarity has been irrelevant for decades. In the mid-20th century, cutters in Brazil, the world's largest source of amethyst, discovered that they could mimic nature's thermal process in just a few hours. By placing amethyst in an industrial furnace at carefully controlled temperatures, typically 300 to 550 degrees Celsius, the purple hue turned golden or amber. The transformation was permanent, stable, and visually appealing. Most importantly for manufacturers, it could be done on a scale large enough to flood the global market. Within a few years, the gemstone trade had changed. Citrine was no longer a stone that miners had to wait years to mine. It was a product that could be produced from existing amethyst reserves whenever demand increased. During the jewelry boom of the 1970s and 1980s, this treated citrine was perfect for commercial designs. It was shiny, durable, and cheap enough to mass produce. Consumers saw the gold stones in department store displays and bought them without questioning their geological history. Investors, however, saw the market differently. They saw a gemstone with virtually unlimited supply potential, no obvious visual distinction between natural and treated stones, and prices determined more by kiln capacity than geological scarcity. Over time, this reality has stripped citrine of any serious investment narrative. While natural, untreated citrine does exist, with significant supplies in Brazil's Minas Gerais and Madagascar's Ilakaka, it occupies such a small niche that even certified specimens rarely make it into major auctions or high-end private collections. For investment buyers, the issue is not beauty or durability. It's that the market treats all citrine as interchangeable, whether it formed in the Earth's crust over millions of years or was fired in a furnace in an afternoon. Today, more than 90% of citrine in circulation is heat-treated amethyst. The market is transparent about this, but transparency doesn't solve the fundamental problem for investors. Any gemstone whose supply can expand at will has no basis for long-term price growth. As a result, citrine has been absent from serious investment strategies for decades, not because it failed as a gemstone, but because it was so successful as a manufactured product. Ranked 9th, Ammolite. Too fragile for the investment game. If citrine slipped out of investor portfolios because anyone could manufacture more of it, Ammolite left for the opposite reason. It could never overcome the limits built into its structure. This gemstone is unique in the modern trade. Mined almost entirely from a single stretch of fossil beds in southern Alberta, Canada, and formed over 70 million years ago from the shells of ammonites, marine creatures that once ruled the seas. Over millennia, layers of aragonite preserved within those fossilized shells developed an iridescent sheen, reflecting reds, greens, and, in the rarest cases, flashes of blue and violet. When the World Jewelry Confederation officially recognized Ammolite as a gemstone in 1981, it seemed to offer everything a niche investment stone needed: exclusivity of origin, a geological story rooted in deep time, and a visual effect that rivaled opal in complexity. The early years supported that optimism. During the 1980s and 1990s, production was tightly managed, marketing campaigns positioned it as a Canadian national treasure, and interest grew rapidly in East Asia, where its color spectrum and organic origins were promoted for both aesthetic and symbolic reasons. Top-grade pieces changed hands among collectors who believed in its long-term potential, and for a time, Ammolite looked like a small but promising entry in alternative gem portfolios. But unlike quartz, corundum, or beryl, Ammolite's beauty is bound to its fragility. Its aragonite layers measure fractions of a millimeter in thickness and have a hardness of only 3.5 to 4 on the Mohs scale. Without protection, they can flake, crack, or dull from handling. To make it suitable for jewelry, almost all commercially sold Ammolite is stabilized, cut as thin veneers, mounted onto shale or other backing materials, and coated with clear epoxy or spinel caps. While this preserves appearance, it also turns most specimens into composites. For investors, that creates an uncomfortable gap between the natural label and what's actually in the piece. It isn't easy to secure high-value liquidity for a gemstone when its most marketable form is partially synthetic in construction. Even its supply story, once a strong marketing point, worked against it in the long run. Ammolite's sole commercial mining region is small, but the volume of recoverable material, combined with the ability to stockpile and release it in controlled quantities, kept the market consistently supplied. Without genuine scarcity pressure, prices never develop the momentum that drives investor competition. In recent years, Ammolite has become more visible in tourist-driven retail than in auction catalogs. Its place in serious investment portfolios, quietly seeded to harder, more stable gems with proven resale records. For collectors, it remains an unusual and beautiful addition. For investors, the conclusion is clear. A gemstone this fragile, with such a narrow and treatment-heavy market, no longer meets the benchmarks for holding long-term value. Ranked 8th, Blue Topaz, the gem technology made common. Blue Topaz is one of the most abundant gemstones in the quartz family, but its current market reality is shaped almost entirely by human technology rather than geological rarity. In nature, topaz occurs in a range of colors, from colorless to pale yellow, pink, or brown, and vivid blues are exceptionally uncommon. For much of history, naturally blue stones appeared so rarely that they held little presence in the trade. That changed in the late 20th century when the industry adopted irradiation as a standard enhancement method. By exposing pale or colorless topaz to high-energy electrons or gamma radiation, followed by controlled heating, producers could create deep Swiss blue and London blue shades that rivaled or even surpassed the color of natural stones. Once the process became established, it scaled quickly. By the 1980s, irradiation facilities in the United States, the UK, Switzerland, and later Thailand were processing metric tons of topaz each year. The results were stable, visually appealing, and, most importantly for mass jewelry production, available in virtually unlimited quantities. Retail sales surged, and blue topaz became a fixture in department stores, television shopping networks, and mall jewelers. For everyday consumers, this was a success. A bright, durable gemstone, Mohs 8, at an affordable price. For investors, it was an early warning. A gem whose supply can be expanded without limit and whose value is tied more to production capacity than geological scarcity has little chance of sustained appreciation. A lack of clear market separation compounded the issue. While reputable dealers disclose irradiation treatment, much of the mass market does not emphasize it, meaning that rare, naturally blue topaz is often priced alongside treated stones. Without a recognized distinction, even the few natural specimens struggle to command investment-level premiums. Auction houses seldom feature blue topaz, and when they do, it appears as part of designer pieces rather than as standalone investment lots. Though its durability makes it an excellent stone for daily wear, durability alone is not enough to secure a place in serious portfolios. With no scarcity factor, no strong auction record, and no market segmentation between natural and treated material, mass irradiated blue topaz remains a decorative success story. But for investors, it is firmly off the table. Ranked 7th, Mystic Topaz, Color without a market. Mystic topaz begins life as a colorless variety of natural topaz, a mineral with a hardness of 8 on the Mohs scale and good toughness. On its own, colorless topaz has little investor demand. Its transformation into mystic topaz comes through a surface treatment known as thin film coating, developed for the gem trade in the late 1990s. In this process, the finished gem is placed in a vacuum chamber where a microscopic layer of titanium or similar metal is bonded to its surface. The result is a permanent iridescent effect, displaying shifting flashes of green, purple, and blue that no natural topaz variety can produce. Visually striking and affordable, Mystic Topaz found an immediate audience in the mass jewelry market. Retailers paired it with silver or lower-cost gold alloys, using its rainbow-like appearance to target younger buyers and trend-driven designs. From a purely decorative standpoint, it succeeded. The coating is stable under normal wear, and the underlying topaz is a durable gemstone. But for investment purposes, the problems are structural. The thin film layer is susceptible to scratching, abrasion, and chemical damage. Once the coating is worn or removed, the gem reverts to plain colorless topaz, erasing the very feature that gave it value. In the investment sector, permanence and natural rarity are essential. Mystic Topaz has neither. The treatment can be applied to any quantity of suitable base material, eliminating scarcity. And unlike color that is intrinsic to a crystal's composition, this optical effect sits on the surface, vulnerable to physical wear over time. Auction houses rarely, if ever, list Mystic Topaz as a standalone stone, and it holds no place in established gemstone indices. For these reasons, Mystic Topaz remains a retail success, but is a complete absence in serious portfolios. It is a gemstone whose identity is defined by a treatment rather than its geological origin. And in a market where investors pay for what the earth created, not what a coating can simulate, that makes all the difference. Ranked 6th, Amber Imitations. That ended investor confidence. In the amber trade, the line between genuine gemstone and manufactured product has been blurred for more than a century. Still, the modern investment market has no tolerance for that ambiguity. Genuine amber is fossilized tree resin, hardened over millions of years, with the oldest commercially traded material dating back to the Eocene period. Its geological stability, warm color spectrum, and occasional inclusions of prehistoric insects once gave it a niche place among collectible organic gems. Yet as demand increased and large pieces of transparent amber became scarce, the trade adapted, not by finding new deposits, but by creating composite substitutes. Pressed amber, also called reconstructed amber, is made by taking small chips of genuine amber, heating them under controlled pressure, and fusing them into larger, workable masses. When done skillfully, the result can mimic the appearance of a single natural piece. Copal, younger, sub-fossilized resin, often only thousands or tens of thousands of years old, adds another layer of complexity. It can be polished to a similar luster as amber and, in the absence of proper gemological testing, can be sold to the untrained buyer as the same material. Both products are legitimate in the jewelry industry when disclosed, but in the context of investment, they present two fatal problems: reduced geological age and altered structure. By the early 2000s, gem labs and trade associations began warning about the prevalence of pressed and copal material in tourist and wholesale markets. Buyers who had paid premium prices discovered their museum-grade amber was either reconstructed from fragments or not ancient enough to qualify as authentic amber in a geological sense. For investors, this destroyed confidence not just in treated pieces, but in amber as a whole. The difficulty of verifying age and structure without laboratory testing made it a high-risk category, and a category with minimal upside, since even the rarest natural specimens cannot easily generate auction competition against established gemstone classes. Today, natural, untreated amber with verifiable age and provenance remains collectible to a narrow audience, particularly in regions with strong historical ties to amber carving. But in the investment world, the shadow cast by pressed material and copal imitations is too long. Without absolute certainty of authenticity, the market treats all amber with caution and high-value portfolios avoid it. What remains is a trade driven by decorative demand, where beauty alone cannot restore the credibility lost to decades of substitution. Ranked fifth, emeralds investors won't touch anymore. Emerald has long been one of the cornerstones of high-value gemstone investment, but its market strength rests on a delicate balance between beauty, rarity, and acceptable levels of enhancement. By nature, emeralds from nearly every source contain internal fractures and inclusions, the so-called jardin, that form during their growth in hydrothermal or metamorphic environments. For centuries, light oiling with colorless cedarwood oil has been an accepted practice, filling microscopic fissures to improve transparency without significantly altering the gem structure. This tradition, documented in historical trade records, did not prevent top stones from setting auction records. The shift came with the introduction of modern polymer resins as fracture fillers. Unlike oil, these synthetic substances penetrate deeper, often harden within the stone, and can carry green dyes to mask pale or cloudy areas. The result to the eye can be dramatic: a heavily included crystal transformed into a clear, richly colored emerald that seems to rival the finest Colombian goods. But to an investor, this transformation is precisely the problem. The gem's apparent quality is no longer a reflection of its natural state, and the polymer, unlike cedar oil, can discolor, degrade, or detach under heat, solvents, or UV exposure. By the late 1990s, gemological laboratories were routinely detecting heavy polymer impregnation in emeralds submitted for certification. Reports began specifying levels of treatment: minor, moderate, or significant. Only stones in the minor category retained strong investor interest as they aligned with historical norms. Those labeled significant faced immediate devaluation, regardless of appearance. This grading shift changed buyer behavior at every level of the trade. Auction houses tightened their acceptance criteria, high-end dealers became more selective, and institutional buyers began avoiding treated emeralds altogether. The long-term consequence is that polymer-treated emeralds have been pushed out of serious investment portfolios. While they remain visually attractive and perfectly wearable, their market position is anchored to retail jewelry, not to collectible assets. In the high-stakes investment sphere, disclosure and stability are as important as beauty, and a gemstone whose appearance depends on a synthetic filler fails both tests. Today, the emerald market is effectively split into two. Untreated or lightly oiled stones continue to command global competition. At the same time, heavily polymer-treated specimens, no matter how vivid or flawless they seem, are left behind. Ranked fourth, B-Jade, the treated jade investors avoid. In Jadiat, reputation is everything. For centuries, untreated A-Jade from Myanmar's deposits commanded the highest prices in the jade market, particularly in China, Hong Kong, and Taiwan, where fine-quality imperial green pieces are regarded as symbols of status and heritage. The material's value comes from its natural translucency, saturated color, and exceptional toughness, properties formed when interlocking crystals of sodium aluminum silicate solidified under intense geological pressure. In this top tier, provenance and authenticity are as important as appearance. B-Jade is the industry term for jadeite that has undergone two aggressive treatments: chemical bleaching and polymer impregnation. First, lower-quality jadeite is immersed in strong acids to dissolve brown iron staining and other surface impurities. This process can weaken the fibrous crystal structure, creating microscopic voids. These voids are then filled with a transparent polymer resin under vacuum pressure, restoring a glassy polish and making the stone appear far more translucent than it originally was. The result can be visually striking, but the gem's internal structure has been permanently altered. In the retail sphere, B-Jade can be sold for decorative purposes when fully disclosed. In the investment world, it is treated as a separate, lower category, one that does not hold or grow in value. Polymer impregnation is detectable under infrared spectroscopy and other lab methods, and certification reports from respected gemological institutions mark such stones. Once documented as B-Jade, even the most beautiful piece is excluded from high-end auctions and serious collector interest. The reasons are both practical and cultural. Practically, the polymer can degrade over time, yellowing or cracking, which diminishes the piece's visual appeal and resale potential. Culturally, jade's market prestige is tied to the belief in its natural, unaltered state. In regions where jade has ceremonial or symbolic significance, treated material is not only less valuable, it is considered unsuitable for heirloom use. Over the last 2 decades, increased public awareness of B-Jade has shifted buying patterns. Major auction houses now include explicit treatment disclosures in jade listings, and seasoned investors focus exclusively on untreated A-Jade with verifiable provenance. The lower-tier material has found a place in fashion, jewelry, and souvenir markets. But as far as high-value portfolios are concerned, B-Jade is off the table. Its market story is a reminder that in gemstones with strong cultural heritage, authenticity is not negotiable. Once that trust is broken, no amount of visual beauty can restore it. Ranked third, Beryllium Sapphire, beauty that broke trust. In the sapphire market, color is the primary driver of value, and among all colors, the delicate pink-orange of a true padparadscha is one of the rarest and most sought after. Naturally occurring stones with this hue come mainly from Sri Lanka, and more rarely, Madagascar, and command premium prices backed by a century of collector demand. Their scarcity and strong auction performance made them a reliable inclusion in high-value gemstone portfolios, until a single treatment altered the landscape. Beryllium diffusion, developed in the late 1990s, involves heating sapphires to extreme temperatures, over 1700 degrees Celsius, in the presence of beryllium. The element penetrates deep into the crystal lattice, altering the stone's color throughout rather than just on the surface. This process can turn lower-value pale sapphires into vibrant padparadscha-like hues or other saturated colors. Visually, the results can be almost indistinguishable from natural stones, even under standard gemological observation. For the jewelry retail market, this was a breakthrough. Enormous, vividly colored sapphires at a fraction of the cost of their natural equivalents. But for the investment market, it was a problem with long-term consequences. Beryllium diffused stones require advanced testing methods, such as LAI-CPMS, laser ablation inductively coupled plasma mass spectrometry, to detect the treatment, and not all laboratories offered such services at the time. This gap allowed treated stones to enter the market without disclosure, eroding buyer confidence and creating uncertainty around any sapphire in the target color range. By the mid-2000s, major gem labs had adopted testing protocols for beryllium diffusion, and auction houses began refusing uncertified padparadscha sapphires. For serious investors, the shift was immediate. Only stones with clear, lab-issued, no indication of heating, or heated, no beryllium detected reports remain viable. The rest, no matter how beautiful, lost their place in portfolios. Today, beryllium diffusion is openly used in the commercial market for affordable jewelry, and disclosure is more consistent. But in the high-value sector, the damage is done. The association between padparadscha colors and the possibility of deep diffusion treatment has permanently reduced investor appetite for any sapphire without airtight documentation. This is one case where a single technological advance expanded availability for the mass market while effectively removing the stone from the investment arena. Ranked second, red Andesine, the feldspar that lost its credibility. In the mid-2000s, a red gemstone with no established track record suddenly began appearing in international gem markets. Labeled red Andesine and described as a rare feldspar from Tibet or the Democratic Republic of Congo, it offered a saturated hue reminiscent of fine spinel or ruby, but at a fraction of the price. Dealers promoted it as a naturally colored gem with limited supply, and for a brief period, investor interest flickered. The color was unusual for feldspar, a mineral group better known for labradorite, moonstone, and sunstone. In this case, the tone was pure, even, and marketable, perhaps too much so. The turning point came when gemological laboratories began investigating its origin. Advanced analysis revealed that much of the material's red color was not natural at all, but the result of copper diffusion treatment. In this process, pale or colorless feldspar is heated in the presence of copper-bearing compounds, allowing copper ions to penetrate deep into the crystal structure and permanently alter the color. The change is stable but entirely artificial, and in the case of red andesine, it created a product with no geological scarcity. The fallout was swift. Reports from institutions like GIA and AGTA confirmed that a significant percentage of the Tibetan and Congo red andesine on the market was treated. Dealers who had paid premium prices found their inventory devalued overnight. Collectors felt misled, and investor confidence in the stone collapsed. Within a few years, red andesine went from being a discovery with market buzz to a cautionary example in gemology courses on how undisclosed treatment can undermine an entire category. Today, copper-diffused andesine is still sold in the commercial jewelry trade, often with disclosure, but its reputation in the investment sector is irreparably damaged. Auction houses avoid it, high-end portfolios exclude it, and even untreated specimens, which are genuinely rare, suffer from the lingering distrust created by the scandal. For investors, the lesson is straightforward. When a gemstone's market value is built on a narrative of rarity, a single breach of authenticity can erase that value. In first place, lead glass ruby, the composite stone investors reject. In the hierarchy of investment gemstones, ruby has always been near the top. The finest untreated stones from Myanmar's Mogok region, Mozambique's Montepuz, or Thailand's Chantaburi have commanded prices per carat rivaling and sometimes exceeding those of diamonds. Their value is built on a combination of geological scarcity, cultural prestige, and a long history of performance in the high-end market. But at the other end of the spectrum lies a product that wears ruby's color but carries none of its investment credentials, the lead glass-filled ruby. This material begins as low-grade corundum, often riddled with fractures, cavities, and cloudy inclusions that render it nearly opaque. By itself, such rough has minimal market value. In the glass-filling process, the stone is cleaned, sometimes lightly heated, and then infused with a high lead content glass under vacuum. The molten glass penetrates fissures and voids, dramatically improving transparency and visual appeal. To the casual observer, the result can look like a fine ruby. In reality, much of the apparent clarity and brightness is the filler, not the crystal itself. The problem for investors is fundamental. Lead glass-filled rubies are composites. Their stability depends on the integrity of the filler, which is far softer and less chemically resistant than corundum. Exposure to acids, ultrasonic cleaning, or even certain household chemicals can etch or cloud the filler, permanently diminishing the gem's appearance. Moreover, because the treatment is both extensive and irreversible, there is no scenario in which the stone can be reclassified into a higher market tier. The global market's encounter with this material in the early 2000s was disruptive. Large volumes emerged from cutting centers in Thailand and were distributed worldwide, often with insufficient disclosure. Buyers expecting heat-treated but otherwise natural rubies discovered their stones contained significant amounts of glass. Major gemological laboratories responded by issuing clear, lead glass-filled disclosures on reports, yet auction houses quickly refused to handle such pieces. Within a short time, the investment market effectively closed its doors to the category. Today, lead glass-filled rubies occupy a firmly commercial niche. They are used in affordable jewelry where size and color are prioritized over longevity or resale value. For investors, they are a complete non-starter. No matter how large, vivid, or visually clean the stone appears, its market value will always be tied to the low-grade material it began as, and the knowledge that what the eye perceives as ruby is in large part glass. In an asset class where authenticity and permanence define worth, that fact alone keeps lead glass-filled rubies out of serious portfolios.